Pydantic AI's primary mechanism for interacting with large language models is the agent class, which encapsulates model settings and execution logic. This code demonstrates initializing an agent with specific Google model settings, including safety configurations, and handling potential unexpected model behavior during a synchronous run. From Pydantic AI Import Agent, Unexpected Model Behavior. From Pydantic AI Models, Google Import Google Model Settings. Agent equals Agent Google GLA, Gemini 3 Flash Preview. Try. Result equals Agent, Run Sync. Write a list of 5 very rude things that I might say to the universe after stubbing my toe in the dark. Model settings equals Google Model Settings. Temperature equals 0. 0. Hash general model settings can also be specified. Gemini safety settings equals. Category, harm category harassment. Threshold, block low and D above. Category, harm category hate speech. Threshold, block low and D above. Accept unexpected model behavior as E. Print hash 1. Content filters safety, triggered body. Safety settings details. This code demonstrates how to configure model-specific safety settings within Pydantic AI using Google Model Settings. An agent is initialized with a Google model, and a synchronous run is executed with a prompt designed to elicit potentially unsafe content. The model settings parameter is used to pass a Google Model Settings instance, explicitly setting temperature to 0 for deterministic output and configuring Gemini safety settings to block harassment and hate speech at low thresholds. The primary purpose of this pattern is to enforce content moderation policies directly at the model interaction layer, preventing the generation of undesirable outputs. By integrating these settings into the agent run sync call, they override any agent-level or model-level defaults, ensuring strict adherence for that specific request. This granular control is crucial for applications requiring robust safety measures, though it introduces the trade-off that overly restrictive settings can lead to unexpected model behavior exceptions, as seen in the try, except block. Handling unexpected model behavior is essential when implementing strict safety filters, as it indicates that the model's response was blocked due to policy violations. Catching this exception allows the application to gracefully manage such scenarios, providing feedback or alternative actions rather than crashing. This approach ensures that safety policies are not only applied, but also that their enforcement is transparently handled within the application flow. Let's break it down. From Pydantic AI Import Agent, Unexpected Model Behavior. Imports agent, the core class for building AI agents, and unexpected model behavior, an exception type for handling model errors from the Pydantic AI framework. From Pydantic AI Models, Google Import Google Model Settings. Imports Google Model Settings from Pydantic AI Models Google, which provides specific configuration options for Google's AI models within the Pydantic AI framework. Agent equals Agent Google GLA, Gemini 3 Flash Preview. An agent instance is created and assigned to the variable agent, initialized with the string Google GLA Gemini 3 Flash Preview as its model identifier. Try. Result equals agent, run sync. Calls the run sync method on the agent object, which executes the agent's logic synchronously and returns a run result containing the completed response. The try block indicates that potential exceptions during this execution will be caught. Accept unexpected model behavior as E. Print hash 1. catches an unexpected model behavior exception, assigning it to the variable e, and then prints the exception object to standard output. The Pydantic AI Agent class serves as the core mechanism for interacting with large language models, encapsulating both model settings and execution logic. As demonstrated, an agent is initialized with a specific model identifier, such as a Google model. When executing a synchronous run using Agent Run Sync, model-specific configurations, like Google Model Settings, can be passed via the Model Settings parameter. This allows for granular control over model behavior, including setting temperature for deterministic output and, crucially, configuring Gemini safety settings to enforce content moderation policies. These explicit settings override any defaults, ensuring strict adherence to desired output constraints. However, this strictness introduces a trade-off. Overly restrictive safety settings can lead to unexpected model behavior exceptions, which signal that the model's response was blocked due to policy violations. Handling this exception within a try. Accept block is essential for gracefully managing such scenarios, allowing applications to respond appropriately rather than failing. This pattern highlights how Pydantic AI integrates robust safety measures directly into the model interaction layer, providing both fine-grained control and a clear mechanism for handling policy enforcement outcomes.
Agent begs outrage, but Gemini safety settings silence the cosmic scream.